Hey everyone, and welcome back to The Explainer. This is where we take complex data and research and turn it all into clear, actionable understanding using the power of visual frameworks. If you're someone who loves to learn visually, you are absolutely in the right place. Today we've got a really fantastic goal. We're going to play the role of visual geometric economists. We are taking our source text on market structures and translating it into a direct mental line drawing walkthrough. We're going to see exactly how market competition literally, physically, bends a company's pricing power on a graph. It's a super elegant way to understand the elasticity spectrum.
So, to kick things off, I want you to build a mental graph right along with me. Picture a totally blank canvas. In economics, whenever we want to map out market power, we always start with two simple lines. On our vertical axis, the y-axis, going straight up and down, we're measuring price. And on our horizontal axis, the x-axis, going left to right, we're measuring output, which is just the quantity of goods sold. Everything we discuss today is going to happen right here, in this space between price and output.
But wait, before we draw our very first line, we need to establish one foundational economic rule straight from our source material. When we talk about a firm's demand curve today, we are actually talking about its AR, or average revenue curve. Our text defines average revenue as total revenue divided by quantity, which, wonderfully, simplifies perfectly to just the price. So, the demand curve simply shows the different quantities of its product a firm can sell at various prices. Basically, when you hear me say demand curve, just think average revenue. They're the exact same thing on our graph.
All right, curve number one, the flat floor of perfect competition.
Let's plot our very first line. I want you to imagine drawing a perfectly horizontal, straight line on our graph, running completely parallel to the x-axis at a specific price point. It doesn't angle up, it doesn't angle down, it is a completely flat floor. Let's go ahead and label this line perfectly elastic demand.
Okay, let's dive into this. Why is the floor completely flat? Well, our source material tells us that under perfect competition, a firm produces a completely homogeneous product and acts as a mere price taker. A single, uniform price rules the entire market. Because the firm's output is literally just a tiny drop in a massive ocean, it can sell any quantity it wants without ever having to lower its price tag. Sell 1 unit, the price is the same. Sell 1,000 units, the price is exactly the same. And this brilliantly illustrates why the AR curve, the demand curve, is perfectly constant. It stays totally flat no matter the output.
Now, that horizontal line is the absolute ideal of perfect competition. But we know the real world is rarely that perfect. So we've got to pivot. What happens to our perfectly flat line when a firm suddenly has 0 close substitutes for its product? Basically, what happens when competition just vanishes?
That brings us to curve number 2, the steep drop of monopoly.
Let's see how this second curve transforms our mental graph. Instead of a flat line, I want you to imagine starting way up high on the y-axis, representing a very high price, and drawing a steeply plunging downward sloping line. It drops aggressively toward the x-axis. We're going to label this line less elastic demand. What's really interesting about this is the geometric reality of imperfect competition. Our source text explains that any imperfectly competitive firm must reduce its price if it wants to sell more output. You just can't sell infinite amounts at the same high price. But here's the kicker. Because a monopoly has absolutely 0 close substitutes, meaning consumers literally have nowhere else to go, this downward curve is incredibly steep. The firm wields massive market power, making its demand curve highly inelastic. They can drop the price, but the quantity demanded doesn't respond nearly as drastically as it would if there were competitors in the mix. So, we have our flat floor and our steep drop. But let's be real. The vast majority of products you and I buy every single day don't fit perfectly into either of those extremes. So what happens to the geometry of our graph if we add rivals? Rivals who are selling similar but slightly differentiated products.
To understand our final curve, we have to contrast these two totally distinct market environments. On one side, we have our isolated monopoly with 0 close substitutes. On the other side, we have monopolistic competition. This is a really fascinating blend. The firm is essentially a mini-monopolist of its own specific brand, but it faces intense constant pressure from the direct existence of rival firms selling close substitutes. Think about toothpaste brands. They aren't perfectly identical, right? But they are absolutely close substitutes for one another.
And that leads us to curve number 3, the shallow slope of monopolistic competition.
That competitive pressure physically alters the shape of our graph. We still start high up on the y-axis because the firm is a price maker with at least some power, so it is still a downward sloping line. But I want you to draw this third line sitting just above the monopoly line, falling at a much flatter, shallower angle. It stretches much further out along the x-axis before it bottoms out. We're going to label this one more elastic demand.
So the crucial point is understanding exactly why the angle changed. It's still downward sloping because, much like the monopoly, the firm has to lower prices to sell more volume. But why is it shallower? Why is it more elastic? The source material gives us the exact answer here. It is significantly more elastic simply because of the direct existence of rival firms. If a monopolistically competitive firm raises its price too high, consumers don't just sit there and accept it, they immediately switch to a close substitute. The sheer presence of alternatives pulls that steep, rigid monopoly drop into a much flatter, highly responsive slope.
All right, let's look at the elasticity spectrum and review our master graph.
Now that we've plotted all three lines, let's take a quick step back and review the whole shebang. We started with step 1, the perfectly horizontal line of perfect competition, where the firm is a pure price taker. Then came step 2. We drew the steep, rigid, inelastic drop of the monopoly, holding total market power. And finally, step 3, we drew the shallower, flatter, downward slope of monopolistic competition, where market power gets diluted by the presence of all those rivals. The level of competition in the market literally dictates the exact geometric angle of the demand curve. Basically, the more substitutes, the flatter the line.
I really want to anchor this entire visual exercise right back to the core text from our source. The text explicitly states, and I quote, "As compared to the demand curve of the monopolist, the AR curve of a firm under monopolistic competition is more elastic because of the existence of the rival firms producing close substitutes." That one sentence completely hits the nail on the head and validates the geometry we just drew. It's not just abstract economic theory, it is a visual reality. Rivals flatten the curve, period.
As we wrap up this explainer, I want to leave you with a quick way to apply this visual tool right now. Think about the very last thing you bought today. Was it a completely uniform commodity, like a gallon of gas? Was it a utility bill from the sole electricity provider in your town? Or was it a specific brand of coffee competing with 3 other shops on the exact same block? Which of these 3 geometric curves does that specific product sit on? Once you start seeing the world through these 3 slopes, the hidden forces of market competition suddenly become entirely visible. Thank you so much for exploring this graph with me today, and keep looking for that hidden geometry in your daily decisions.